vuestra asistencia a la charla titulada Otro parche más. No, por favor. Lo primero que voy a hacer es presentarme, ya que la mayoría de vosotros no me conoce. Mi nombre es José Vila, soy ingeniero informático que actualmente está trabajando en una empresa que se llama A+, y trabajamos en la división de laboratorios, donde nuestro principal cometido es evaluar productos tanto a nivel hardware como software, siguiendo un conjunto de normativas, como puede ser la 15.408 o bien conocida como Common Criteria. Bueno, tenéis un poco más de información en la transparencia y cualquier duda podéis siempre escribirme al correo. Bueno, el motivo de esta charla, que es por lo que estoy yo hoy aquí, no es enseñar a una persona ni a vosotros un conjunto de directrices de cómo hacer software, sino a donde quiero yo llegar hoy es hacer una reflexión sobre cómo estamos haciendo el software, cómo se está tratando el ciclo de vida del software y la repercusión que tiene esa manera de trabajar. Primero voy a empezar por lo que más me preocupó y por donde empecé a tirar del hilo. Resulta que conforme me metía en diferentes plataformas o actualizaba los programas, veía cada vez más el mensaje de algunos errores corregidos, algunos problemas de seguridad corregidos, bug fixes, etc. Esto me parece notorio porque a la altura que estamos hoy en día, cada vez que se mejora un software, no tenía mucha lógica que la mayoría de las descripciones y conceptos de actualización estuvieran solamente orientados a corregir errores. Por otro lado,
different versions. We have 6.0, 6.3, 5.2, but right now we have a trend in programs, in software, to have a major, a minor, a revision, different versions, and lots of information. And it seems that people are just working without a good structure. Another thing that we need to remember is the security awareness rating is growing a lot. On the other hand, we see that the number of patches and updates is also growing. And this brought to mind a series of questions. Is this really positive? Are people patching because they found vulnerabilities, and are they applying the knowledge to detect them quickly? Or is this because we're being less careful in programming? Okay, so to do this analysis, one of the things that I thought would be convenient was to look at the number of vulnerabilities we have currently. So you come to 2017 and you find an interesting piece of information. 14,709 vulnerabilities have been detected this year so far. What does that mean? It means that in 2017 it's been the year where most vulnerabilities have been detected in comparison to the rest of the years. It doubles up the figure of 2016, and this could be an interesting food for thought. So we may think that the techniques have improved, but people are beginning to apply new methodologies when it comes to tech things, and that's where we find many more vulnerabilities. However, many of those techniques are showing some small flaws that no one realized about earlier, and people are working on them now. But this year, if we look at how we're at, in 2018, we're going to follow the same trend. In 2 months, in the sixth part of the year, we have found 2,605 vulnerabilities. That's more than 15,600 altogether in the year. And if we do an analysis and we look at the focus on a certain type of category within programming or the area, we realize that it's quite well distributed. We have a third for applications, about a third for operational systems. Mobile devices are not lagging behind. And what is the important bit here? We need to think that when you have a software that you're developing, you're going to use an operating system, a set of libraries that you're going to apply in your software. And they'll probably also have vulnerabilities. And this is yet another stage in the development of detecting vulnerabilities. So did you get to look at the set of programs that you're using? And maybe I'm crazy, or I have a problem, or I'm getting the numbers wrong and I'm achieving the wrong conclusions. But when I go on the internet and I find these kind of headlines, I start researching and I see that people are alarmed by these figures, and I think that this should be concerning for all of us. So with this idea, this concern in mind, let's do some analysis. And I'm going to focus this analysis first on how developers and companies are looking at security. First of all, we realize there is an excess of confidence. Even though there is lots of training and we're trying to raise awareness on security ideas, people are still despising, so to say, and rejecting the problem for their own software. So you go and say, well, this problem will not affect me. This for software such as Skype or Windows, but who's going to look at my software? So what does this bring? This brings about a lack of training. There are companies that are not aware, and they do not give the developers the needed skills to develop secure software. So what happens with this? The developer, when they read an article, and they go into a blog, and they go to a website for more secure development and a lot of documentation, they find that they need to work a lot and that it's difficult to carry out that work. Most people laze around, they don't look at these concepts, and this generates that you may have vulnerabilities in logging, in the access, in database access, in input validation, and so on. And these questions is something we should think about. Have you ever heard them? I have, very often. And I may have committed this thing of thinking of them sometimes. Not just these questions and this way of thinking, but whenever you find someone who does pen testing and audits and who works on all of this, you find that, well, I got the software of a friend that they're developing on his company, and since I know that they have a couple of vulnerabilities, I want to tackle that. And they're amazed. So if we take as a basis that the software may have vulnerabilities and that people are not correcting them, maybe we're doing something wrong. Another way of seeing this is on the actual development. So we have a cycle when it comes to developer software with different stages where security is extremely important and you need to start designing an analysis. I do apologize, I kind of lost my slide. Okay, I got it. So as I was saying, and I do apologize for the interruption, in each stage of the development of the software, you need to apply a set of methodologies. To do secure and stable software, you need to apply these set of methodologies. And we begin with the stage of requirements.
En diseño, un modelado de seguridad, estudiando lo que puede afectar a nuestro software, hacemos una revisión de código en la implementación.
So we do a code review for implementation, a static analysis of the code, and afterwards, in the tests that assess our product, we apply some dynamic analysis, penetration testing, just to look at how that software is made, and eventually get a product ready to be delivered. So what's the problem here? The problem is that this brings about a higher security cost when it comes to generating it. You need to invest a bigger amount of resources than you thought of, and then you have a development for the long time. You cannot tell a customer that you're going to integrate it in a month or a week. They need an assessment and to calibrate those times. On the other hand, what do we get? Well, we get a low error rate or low fail rate, a more stable code, better reviewed, and easier maintenance. This will be a model applied to security. So how do companies perceive it? They have the kickoff meeting, they have the product they want to offer at the end of the project, and everyone is happy, and we have it in a perfect software cycle. The problem is that as a quality contribution, we're trying to reduce the delivery time to the customers so that they may have this quick service and we may generate money. And here's the question: how will we be able to put all these phases in this period? Well, usually companies put them in requirements plus design, and you try to do it on the go and to do it right. And of course you need to lengthen the implementation and the coding, because there are things that are not very stable, and at the end of the cycle you have certain gaps that you need to cover. And you need to do full testing, and when you have a product, you have an uncontrolled state that may generate many mistakes afterwards. So what does this result lead to? On the one hand, this may be good for the company: less costs, less time, a quick turnaround. But what is this giving us? A high bugs rating, a unstable code that is not well tested, and a more complex maintenance. And the question here is, does this really bring true benefits for the company? Is this what the company wants? So the first con regarding this benefit is how it happens once you have it on production, fixing on demand. To prefer to fix the problem in maintenance eventually generates a high cost on the actual product. And the real benefit of the product, you may see it as, well, if I program for how late months and I give a stable development to the product, for a certain period I'll run out of money. So if I split it, I'll gain for months if I shorten that to 4 months. So we need to look at whether that's beneficial regarding the stabilization of the actual product. And the effort invested in these two items needs to be understood. Eventually, the maintenance stage, in that stage it's harder to fix problems than in the early stages of the software, and the associated cost of fixing the problem has an exponential growth. You need to go back some stages and fix it. Without further ado, or without looking for more difficult problems, we can look at the example of Skype, and we have other associated problems, such as having the resources invested in another project, and we need to move them again and leave that project aside. So we lose the trust of the customer, because if the fail rate increases, the customer will be reluctant to use that product, and they may not talk well about you. And then the pressure, when you have a project and you have other objectives and you get to work on another project and your times are not right, that puts pressure on the developer, and the programming is worse. So how can we approach these set of things? Well, we're going to try to split that in three concepts. What we all need to take into account, first of all, is integration. Integration of methodologies in development is essential. And I think that people should make an effort in applying those methodologies, such as threat modeling, I've mentioned earlier, applying a design of threats to your product, and assess the risks of those threats. And the concept of TDD, security oriented, which is a concept that is being developed by WASP, which is very interesting, where you're not just directing development but testing of how the product works, but it's also geared towards the vulnerabilities that may arise. And another part that is more important for me are the external assessments. But this also has a positive point. But when you are a developer and you know your product and you know what the problems are, In fact, you're doing a test and an analysis of the problem that it may have, geared towards what you have programmed. However, if you give it to an external company, someone who doesn't know your product, and they test it comprehensively, maybe with these you can get a software with better quality. And what's the concern here? It's important to understand the risks. And this is connected to what we had above. It's not just the design, but also keeping in mind all the risks that may be brought about by having unstable software or by doing brainstorming with a whole set of developers and project managers, so that they show different vulnerabilities or problems that may arise. And you may study which users have the system, but also the ones that are not going to use it. The people who are going to get your product are going to try to spoil it and get a profit out of it. So you need to keep in mind that you don't get short of time. You need to respect the process and the way of doing the software. With the developers, and we usually despise the work when we should be applying much better the awareness of how much our work is worth and how spread it is. Some people keep it in mind and some people despise it, usually in top levels. And last, training. It's important that companies can give their employees security training. That's one of the most important elements to comply with what we mentioned earlier, because may have in mind the type of analysis that they didn't have earlier. So altogether, we need to align the team here so that everyone does their bit for secure software development. And after all of this, the conclusions are, I personally am very concerned with the number of vulnerabilities and problems that have been found in 2017. I have the slight impression, as we've seen, that people tend to patch and update the software in production constantly, and I'm not sure that's positive for our software. However, we do have a massive amount of resources that we can apply to our software so that we may create good quality software that is not suffering attacks from people who try to spoil it. So, will we need to give this talk again? Thank you very much.
Hola, muchas gracias.
Hello, thank you for your talk. So I have a question on the usage of semantic versioning. Do you think that most development teams know about it? Yes, I'm talking about semantic versioning. Do you think the development teams know about it? And secondly, is your strategy feasible in Agile Scrum projects? Well, I think that in all sorts of projects, this type of methodology fits. Brainstorming is one of the parts of Agile. To talk as a whole, but this is just not focused for one or another methodology. What we're trying to approach here is to apply it and to make people aware of the fact that they need to apply it. And maybe in that brainstorming time, they may need to align all the team or to devote some time to think on the problems the software may have, not just for the further stages of the product to bring it ahead. Regarding the first question, I see that most developers, maybe not the ones who come to this conference, are not able to apply certain techniques. And I don't think, as I said in one of the slides, I don't think we're able to give the right value of the software and the final quality to apply that kind of technique. And I hope that answers your question. Any other questions?
Igualmente, gracias por la charla. Tengo una pregunta.
Thank you for your speech. Regarding the internals tool development, which quality would you suggest regarding the application of security techniques? Well, tools for testing or your own tools that you're going to use afterwards? Well, tools developed in the company maybe for other people. Maybe they generate files. They do things for other people, if you know what I mean. These are usually small tools that have their own requirements. Well, in fact, I think the company has a more relaxed responsibility, and they're saving a bigger gap because that product isn't going to be launched, made public. It's going to be an internal tool, so devoting resources from the company to bring it out and do it might be very costly and not very beneficial. Maybe one person will benefit from that if they know that they have errors in programming, and maybe they can try to exploit it to manage to have access to resources in the company. When you don't securitize a communication channel in a local network, the same thing may happen, and someone may have hacking techniques and get into that channel and listen to your conversations, because eventually the company has not given value to that. To be honest, I haven't thought about it from the internal tool perspective. Well, we might need to assess whether at all times in the process it's necessary to apply that, because in the life cycle of an application you use that tool. Maybe that tool is giving you a more indirect way of doing things, so we might need to look at that. Possibly, as I was saying, if at some point we could have a chat or a round table or share different opinions, these kind of ideas will be very interesting. Thank you. Okay, we do have time for yet another question. Hi. Congratulations for your speech. It's been very interesting. And I'd like to talk about a problem I see very often. People who work on development are not usually interested in security. And people who do security are not usually very interested in development. In fact, hackers hardly know how to develop in Java and other big applications. So what I wanted to mention is, do you think that we should go towards a model where we embed into development teams people who know how to develop and about security? Instead of developing, they just review the code security? Well, within the secure development process, and by the way, thank you for the question, within the secure development process, you need to have a team in charge of securitizing that project. That is, the application is not just development, we want to develop it securely. In my first jobs, I worked as a developer, and gradually I transferred to security to end up as an evaluator, rather than doing pen testing and assessing the product now. And I also have a certain controversy with that problem, because those two extremes are kind of isolated from each other. Some people may share it, but someone who wants to do hacking is not giving value to development and programming, but they're rather oriented to doing red team or blue team, oriented to infrastructure of the attack. So I think that it's necessary for companies to include in their staff people with security knowledge, and also that developers don't just have someone specialized, but also that they're given that training, that they're given all that, so that their mind gets to a threshold where they may be able to balance out the two versions of how they're working. Thank you very much for your question. Thank you very much, everyone. Thank you. I hope you enjoyed it. Thank you.